problems are C 1 plus A, B, C, A 1 plus B, C, A, B 1 plus C. What I am doing means indirectly here, I am writing in place of C1, C1 plus C2 plus C3 once again. Adding these three values at place of C1, that is 1 plus A plus B plus C. 1 plus A plus B plus C. Here A plus 1 plus B plus C. Here A plus B plus 1 plus C. Remaining column 2, column 3 as it is same. B 1 plus B, B. C 1 plus C. Here 1 plus A plus B plus C. This is also 1 plus A plus B plus B. This is also 1 plus A plus B plus C. Just I am taking common 1 plus A plus B plus C common. With that 1 1 1. B 1 plus B. B C 1 plus C. Here what I am doing means I am doing these two elements as zeros. By using this element, here 1 having 1 minus 1 is going to be 0, 1 minus 1 is going to be 0. That's I am changing here in place of R2. I am doing R2 minus R1 and R3 tends to R3 minus R1 once again. See, already 1 plus A plus B plus C is there directly. And here first row is 1 BC. Second row 1 minus 1, R2 is value is 1, R1 value is 1, 1 minus 1 is going to be 0. R2 value is 1 plus B minus R1 value is B, 1 plus B minus B is nothing but 1. Next R2 value is C, R1 value is C, C minus C is nothing but 0. Here 1, R3 tends to R3 minus, R3 is nothing but 1, R1 is nothing but 1, indirectly 1 minus 1 is going to be 0, B minus B, R3 minus R1, R3 minus B is nothing but 0, R3 is nothing but 1 plus C, R1 is nothing but C, 1 plus C minus C is nothing but 1. Simply if you see here, you will get here what? Upper triangular matrix. The determinant of upper triangular matrix is 1 plus here already 1 plus A plus B plus C is there. The determinant of upper triangular matrix is simply product of principal diagonal elements into 1. The answer is going to be 1 plus A plus B plus C. If you remember this problem as a result, it's going to be good for your health. You won't get any tension by seeing the question. You can answer that is 1 plus A, B, C, A 1 plus B, C, A, B 1 plus C all else is going to be 1 plus A plus B plus C. Here same, here by seeing the question, now you have to answer this question indirectly. By seeing this question, you are going to understand what indirectly. Here see, in row number 1, A square, AB, AC is there. In each and every element we are having A common. A square nunchi lediyach, AB nunchi lediyach, AC nunchi lediyach. Same as from row number 2, you can take B common. From row number 3, you can take C common. What I am taking? From row number 1, take what? A. From row number 2, I am taking B. And from row number 3, I am taking B common. C common. To understand you people, just I am writing. That's nothing is there. That is going to be, here the answer is going to be equals to from row number 1 A, from row number 2 B, from row number C, that is going to be minus A, here B, here C, here already B checking, that means A minus B, and here B is cancelled, that is C. Here from row number 3 we taken C, that is A, B minus C. Once again, here from column number 1, you take A common, come column number 2, B common, come column number 3, C common. Here from here A, here B, here B, C, we are taking common. That let's take the common, that is already A is there, A into A square, into B square, into C square. That is going to be minus 1. 1 minus 1 1 minus 1. Once again I am doing these two elements as zeros by using this row, that is going to be R2 tends to R2 2, here already minus is there. If you write minus, you will get a plus. If you take plus, 1 minus 1 is going to be 0 simply, and R3 tends to R3 plus R1. Now come on, that is A square B square C square. A square B square C square into first row change gale minus 1 1 1, second row that is 1 minus 1 0, minus 1 R2 equal to minus 1 plus R1 equal to 1 is going to be 0. Next R2 equal to 1, R1 equal to 1, 1 plus 1 is nothing but 2. 1 plus of minus 1 is going to be 0. 1 plus 1 is going to be 2. Minus 1 plus 1 is going to be 0. Here see, the answer is going to be A square B square C square into, if I expand this matrix by using row number 1 or column number 1, minus 1 into this matrix determinant, that is 0 minus 4, 0 minus 4, minus 0 plus 0. That is minus 1 minus 4 is nothing but plus 4. Simply 4 into A square B square C square. The answer is going to be 4A square B square C square. Simply, if you remember this one as also result, you are going to get very easily. Here for that problem we got 4 into A square B square C square. Here simply what we are doing, simply whatever the elements we are getting here, we are doing as zeros to get into upper triangular or lower triangular matrix. And also if two elements as zeros, by using one element we can expand a determinant very easily. That's why simply we indirectly are doing zeros here. Okay, let's see some other results also here. Let's see some more results and also problems. Okay, let's see this problem. Here is given one matrix and is saying what this is singular matrix. Actually, we have to know about singular matrix. Singular matrix is nothing but if determinant of A equal to 0, then A is said to be singular matrix. If determinant of A equal to 0, then A is said. This matrix is said to be singular matrix. If determinant of A not equal to 0, if determinant of A not equal to 0, then A is said to be non-singular matrix. Non-singular matrix. If singular matrix is given indirectly, singular means determinant equal to 0. Non-singular is nothing but determinant not equal to 0. Some matrix determinant not equal to 0, like previously we got 1 plus A, B, C, A, 1 plus B, C, A, B, 1 plus C. You got 1 plus A plus B plus C. It is not equal to 0. That is non-singular matrix. Some matrix 1 omega square 1 omega square 1 omega. That is cube root of omega is cube root over. You got 0. That type of matrix is said to be singular matrix. Sometimes he will give the matrix. It is singular or non-singular also he will ask. In the options he will give diagonal, singular, non-singular, none. Based upon if you want to say it is singular or non-singular, compulsory we have to equate that matrix determinant equal to 0. Here we given unknown. To save an unknown, one equation is required. That equation is indirectly x 1 1 2 3 4 1 1 1 equal to 0. Equation equal to 0. That going to be equation. If you simplify matrix determinant, you will get one equation. Always we said the determinant of a matrix, that is will be any order 2 by 2 or 3 by 3, that always is going to be a number. Indirectly it simplified to a number. That by using this unknown, that is the variable, we are going to get one equation. By using that equation you have to solve. Simply nothing is there. How you are getting indirectly, you have to write one here x, here here 1, simply multiply 1 into 2 into 1, that is 2, x into 3 into 1 plus 3x, next 1 into 4 into 1, that is nothing but 4, minus half, 1 into 2 into 1, 2, 1 into 3 into 1 minus 3, 1 into 4 into x minus 4x equal to what? 0. If you simplify, plus 3x minus 4x minus x, next 2 plus 4, 6 minus 5 is nothing but 1 equal to 0. Based upon that, x equals to 1. Always you have to remember that is always determinant of a equal to 0, then it is said to be singular matrix. If determinant of a not equal to 0, then it is said to be non-singular matrix. Always singular matrix and non-singular matrix are very important. Here this is like I have to treat like as a property. If determinant equal to 0, singular. If determinant not equal to 0, it's non-singular. This type of problems are asked so many times. This is 2010 ECET question. It is asked in ECET in 2010, but so many times in 2019, 2016, 17 also given singular matrix, but simply determinant you have to equate to 0, then you will get singular matrix. By using this equation, you asked this unknown indirectly. By this equation only we are saying this unknown. It's a very easy. Okay, let's see more results here. Okay,